So following on from the previous video, we got to a stage where where we started out with y equals a to the power of x, we would differentiate it, it would then give us this thing here, and then we got to a stage where we can interpret this block here as being the gradient of this graph here at x equals 0. Okay, if you start out with y equals a to the power of x, differentiate it, it will give you this. So normally we don't really understand what this block means, but now we can interpret this block here as being the gradient of this graph here at x equals 0. So if you have a graph y equals a to the power of x, it will give you this purple line here. Now that block above earlier is really well, it can be represented as being the gradient of this graph here at x equals 0. Okay, so that's at the end of the previous video. So what that means is that if you have a graph of y equals 2 to the power of x here, you're going to get, when you differentiate it, you're going to get some constant here times 2 to the power of x. Well, this constant here, well, you can interpret it as being the gradient of this graph here at x equals 0. So this number here is this gradient here. And then in one of the earlier videos, I guided you through being able to work out this block here. Well, that gradient here is roughly 0.69. And the way we did it last time was that this block here is this block here. But then we interpret this, we translated it, this limit problem into a graph. So we plotted a graph of y equals 2 to the power of x, take away 1 divided by x. We plotted a graph, and I don't know, I can't remember what it looks like, something like this. And then we interpret this problem as well, we translated this problem into a graph problem here, and then looking at this graph, we would start out this, and then x would slowly approach 0, and then start here, x approaches 0, and then it approaches this figure here. Now, if you don't understand this bit, then track down one of the earlier videos. Well, anyway, when you start out with y equals 2 to the power of x, differentiate it. Hang on. Differentiate it, it will give you some sort of constant. It will give you some sort of constant. Well, this constant here is the gradient at x equals 0, and it turns out that this block here is roughly 0.69 times 2 to the power of x. So when you have a graph of y equals 3 to the power of x here, if you differentiate it, it will give you some constant times 3 to the power of x. Well, this constant here is one way of trying to understand this block here, this constant here. Well, this constant here is really the gradient of this graph here at x equals 0. Now, once you've got that gradient, you will really have yourself in a way a formula for working out the gradient at any point on that line. So, starting out with this, differentiate it, it will give you a number that you don't know, but then this number that you don't know really is the gradient at x equals 0. And then again, we did in one of the earlier videos, we showed that this number is roughly 1.10 because we translated this thing here into a graph problem, y equals 3x minus 1 over x, and then plot the graph, and then get x to move towards 0. So get x to move towards 0, and then here get x to, well, this point here, well, in one of the early videos, we've already settled that this number here is roughly 1.10. Okay.